One of the key parts of driving your project forward is being able to identify and tackle wastes. We heard about three terms often used together in the Toyota production system and called the three M's: Muda, Mora, and Mori. Muda is the first of these and is the most talked about. Muda is any activity that consumes resources without creating value for the customer. The fundamental elements of Muda can be remembered by the acronym TIMWOOD. TIMWOOD stands for transport, inventory, motion or movement, waiting, overproduction, overprocessing, and defects. We will look at each of these in the following slides. T is unnecessary transport. By far, the biggest example of unnecessary transport in construction is double handling of materials. These are passed along the supply chain and delivered to the site where they are usually stored in a temporary, convenient place. The prevailing system and business thinking encourages materials to be purchased in large numbers, owing to economies of scale, and to be brought to the site as early as possible, incentivized by the payment system. For example, a small construction company in London had a problem with materials logistics in a new 8-story social housing apartment block on a tight site. The block was barely weathertight, but all the doors had been delivered, and the only place to store them was in a couple of ground floor rooms. The consequence of this was that they needed to be moved in bulk up the building as apartments were completed from the ground up. This was a lot of extra transport of materials, and many were damaged during the continuing movement and storage. The problem was resolved by arranging for smaller batches to be delivered just in time, so the materials could be taken straight to the place of installation. This removed the need for double handling and reduced the instances of damage. The counter-argument to this, often put forward as a criticism of JIT, is that there are more vans on the road doing more miles. This argument will reduce as vehicles move away from fossil fuels. The costs associated with double handling hours at least equate to the increased number of driver hours, and in addition to that, the cost of damaged and obsolete goods caused by bulk purchases is quite influential. It is truly shocking how many components aren't even taken out from the packaging before being put into the landfill skip during the project. Not to mention the things that are simply dropped and discarded. I is excess inventory or working process. Excess inventory also relates to materials being brought on site too early. It is just spending money unnecessarily. This picture shows how congested the workplace can get. This inhibits the flow that lean project production relies on. This inhibition of flow causes another more serious consequence, that is, starting work as soon as possible or even wherever there is a space. This means work is started out of sequence, becoming work in process rather than work completed in order to facilitate the next task. Lots of tasks started can make it difficult to finish as resources may not be available. Starting work out of sequence and without screening all 8 flows to remove constraints is called making do, a source of waste in construction identified by Koskela. M is excess or inappropriate movement or motion. This source of waste is very under-considered in construction, as responsibility for day-to-day working methods are passed down the supply chain. Toyota recognized that tasks that required awkward and difficult movement from people make the work more difficult and therefore take more time than they need to. Additionally, these bad movements add physical stress, cause at least premature tiredness and at worst injuries that affect productivity. It can be said that poor working practices that cause physical stress to workers can be considered to be long and slow accidents that may not be recognized for several years. This means that the workforce becomes considerably less effective over time. Poor working methods that can cause physical stress in stretching, twisting, and supporting heavy weights are an occupational health hazard, apart from the risk of injury, which is a safety hazard. Because projects are temporary organizations with a transitory workforce, it is difficult to see direct cause and effect. Some things are known, such as hand or arm vibration and strains from lifting heavy weights, and have been addressed through legislation, at least in the UK. In this photo, the operative is twisting and bending awkwardly, and he is kneeling without knee protection. The method of work here has not been thought through, and no facilities are provided, for example, a workbench. How long do you think it will be before he has difficulty bending and kneeling? The consideration of work method is called ergonomics and is an important area in most industries. It is also important for construction and fall under the health part of health and safety legislation, specifically occupational health legislation. Here is another example of poor working methods that can cause physical stress in stretching, twisting, and supporting heavy weights. This photo also shows a different waste, that is unnecessary waiting and delay. Here you can see one person simply standing, and this method also takes longer and therefore delays completion. Bear in mind that we are talking about unnecessary waiting. In theory of constraints, some waiting is necessary to keep the system balanced. An example of this was demonstrated on a Highway England project, when the street lighting subcontractor was paid to stay on site even when not working. This was to avoid any delays in laying blacktop as the critical activity that could be caused by having to wait for the street lighting contractor to arrive. To have the lighting company wait was considered to provide good value, because throughput of the project as a whole is what counts, and optimizing individual parts is not important. O is over or unnecessary production. It is hard to see overproduction in an engineering to order project, as we only deliver what is ordered. However, there is definitely overproduction in the supply chain caused by over-ordering materials. Unnecessary production is perhaps more common where the wrong things are done. This is more likely to be the case when work is done out of sequence, as problems emerge further down the line. One important thing to note is that adding value is not delivering more product than required, as it is sometimes claimed. Delivering more product than required is adding cost, not value, and is overproduction. Another O is overprocessing, which is common in highly bureaucratic organizations. Inappropriate processing is more common on construction site, especially as things are not completed properly. Here we can see that there is no proper system for removing offcuts, so they remain on site, causing a safety hazard and potentially preventing the next task to start. This certainly requires someone to return to the workplace to tidy up and remove the debris. Often the trade leaving the mess doesn't tidy up, and it falls to possibly the next trade or to someone else to go in and remove the pieces. The final D in the acronym stands for defects. These are things that are broken or don't work properly left in the installation. The example here are the air handling units damaged by the plasterboard dust. These were fitted and the defect not discovered until commissioning when they didn't work. This defect was caused by inappropriate processing. A lack of workbenches forces workers to do their work in an appropriate way, creating rework and contributing to cost and time overruns. But defects don't only occur on site. Here is a defect that occurred in design stage and has gone on to become a defect on site. This just isn't going to work. But more than rework, we need to be redesign, as resetting the bracket is more difficult than it looks and very inaccessible. So these are the so-called 7 wastes that often form the focus of lean implementations. And in general, these are the best places to look for what is unnecessary. The items on the list are both outcomes and sources of waste. For example, excess movement, overprocessing, and overproduction can use resources without creating value directly. But they also have indirect impact by causing defects, waiting, excess travel, and work in process. So the classification is not that straightforward.